quantification of malaria parasite, we always use the thick and thin film. Of course, you can see I have a micropipette adjusted to 6 microliters. For the thick film, we use 6 microliters of blood, and for the thin film, we use 2 microliters of blood. Of course, it's always standard when examining malaria, you use both the films, thick and thin. Thick film is for detection, and then for the thin film is for specification and identification of various species of malaria. Yeah, always use a spreader that is smooth. Of course, this side is rough, so I will turn it over. Wow, this side is okay. That is my thin film. Now let's make the thick film. After this, just air dry your slide, then do the staining. After staining, we proceed to microscopy. Yes, so from here I identify different types of malaria, and from here, this is the thick film. We have the malaria parasite, you can see them, and the white blood cells. From the thin film, you can see the parasitized RBCs, malaria parasite, and the normal RBCs. Now, this is how we report malaria. First, we identify the stages of malaria. The first one is the trophozoites. Yes, yeah, trophozoites. After trophozoites, we have the schizonts. Yes, we have three are the major stages that are normally seen under the microscope, and the third one is gametocytes. So these three, they are always easy to identify under the microscope. Merozoites, not quite easy. Then the species of malaria that are well known, we have Plasmodium falciparum. This is common in western parts of Kenya. Yeah, and it's very common in Kenya actually. And the next one we have Plasmodium malariae. The third one we have Plasmodium vivax. The fourth one we have Plasmodium ovale. We have the fifth one Knowlesi, but it's still under research, so we don't know it better. Now let's come to the quantification. So on our slide, let me make a sketch of our slide here. So let's assume this is the slide that we were examining under the microscope. Of course, you have to label the slide with the details of the patient name, and then the lab number. You can even write the date if you so wish. It's important. This is our thick film. It's not perfect, but yeah, just take it as it is. That's our thick film. Then again, we make a sketch. Let's make a sketch of 6 microliters, of course. And then we proceed to make a sketch of the thin film. Remember, thin film we said is 2 microliters, so it only needs a small volume of blood. Yeah, so it has the head and the tail. So mostly when you're doing microscopy, we always concentrate on the tail, because in the other parts of the thin film there is a high concentration of red blood cells, so counting might not be easy. So these are our films, both in one slide. Remember, it's always important to have both of them when doing malaria microscopy. Yeah, like I said, in the thick film we do the detection, then in the thin film we do a specification of different types of malaria, and even counting is always easier at this point. Identifying different species of malaria using the thin film is always easier compared to thick film, so that's why it's always important to have both of them in one slide. This is a sketch of malaria parasite. It's always a dot and a ring, or a comma shape. Yes. When you keenly look under the microscope, if your patient has malaria or the sample had malaria in it, you won't miss that. This is a sketch of white blood cell, particularly it's the neutrophils. So when you want to quantify malaria parasites, you should be having a tally counters. Two, of course. One is for counting the malaria parasites, and another one is for counting the WBCs. Yeah, so that's malaria parasite. This is a WBC, white blood cell, particularly the neutrophils. Yeah, so this is the shape. We have others like basophils, eosinophils, but in this case let's just use the neutrophils because they're always very common in cases of malaria. We proceed to as you can see, if you check on this, it's somehow impressive. Yeah, so just have your tally. If you don't have tally counters, you can always have a paper and a pen. So if you count WBCs, you tally them. If you count the number of parasites, you tally them. Then when counting WBCs, immediately you reach between 200 and 500, you just stop counting. Yes, between 200 and 500, just stop counting. And by that time, you will have counted a good number of parasites. So from the data you have collected from the tallying, we now proceed to the calculation of the parasites and now reporting. In 1 microliter of blood, the estimated number of WBCs, white blood cells, is always 8,000. So in 1 microliter of blood, we have 8,000 WBCs. You can see that. With all this information, you can now calculate the parasite density in the slide that you made using the formula number of parasites counted over number of WBCs counted. WBCs is white blood cells times 8,000 WBCs. So these will give you number of malaria parasites per 1 microliter of blood. So when reporting, it's always easy. So when doing microscopy, we always go this way. So this is our field. You move from this point to this point, then that way, and when you do it this way, it makes it easy to examine all parts of this slide in a particular field. Now let's assume we counted 150 malaria parasites over counted WBCs of 500 times 8,000 microliters. This formula gives us the density of malaria parasites in a particular sample or in the slide that we just made. With our good division method and multiplication, we'll arrive at 2,400 trophozoites of maybe Plasmodium falciparum or different species as per what you saw, and you report it as per microliter of blood. Remember we said 8,000 WBCs per microliter of blood. It's that easy. So this is for thick film. Maybe we can go ahead and try doing it using the thin film and just note the differences that might be there. Again, let's draw a slide. Same case. Now we want to do the thick film in this. Let's just do the thin film now. Yes, that is the side that looks like a cone is the tail. So we always use the tail for examination. Because at the tail region there is evenly distribution of red blood cells, and even seeing the malaria parasites in them is always easy. And malaria parasites inside the red blood cells, those are now inclusions. They should not be there. They are now red blood cell inclusions. An example is that the circular one is the red blood cell, then the dot and comma is the malaria parasite residing inside the red blood cell. When doing malaria microscopy using the thin film, the technique of microscopy remains the same. Of course, you can do it sideways down or up, sideways down, sideways up, sideways down. The technique remains the same. So when counting, in this case we always count number of red blood cells that are infected with malaria parasites, and the total number of red blood cells, the infected ones and those that are not infected. So immediately you examine 20 fields, which is equivalent to 250 red blood cells. You just stop there and then start your calculation. Now the formula is now not the same as the other one. So the parasite density is now equal to parasitized red blood cells over total number of red blood cells, both infected and the normal ones. Then we multiply by 5 million. The estimation of red blood cells per microliter of blood is 5 million. So that's why we are multiplying by 5 million. Yes, this is somehow interesting. Now, let's assume you counted 100 parasitized RBCs over total RBCs 5,000 times 5 million. When you divide and multiply, you'll have 100,000. So this 100,000 will be our malaria parasites. So you report it as 100,000 trophozoites of Plasmodium falciparum per microliter of blood. If you like this content, give it a thumbs up.